For this training assessment, we are going to discuss 3 standards. So the first one is I can determine the variables necessary to solve a problem and the constraints of the problem based on the context. So we really just want to explain what's going on in the context of the problem. So the first thing you want to do is to define your x and your y value. So if you read the problem, it says the yearly population of a city since the year 1995 can be modeled by the equation. So then we give you the equation, and notice that the equation is set up into y equals a times b to the x power. So with that, that's our general form. The a stands for something and the b stands for something. A is the initial value, so the starting value. And the b is either the growth or decay, depending on what the b is. So it could be either or, and you can put factor. So the x and y, that's just specific. What are we talking about here? Well, we are talking about population, and we're talking about over years, so and time. More specifically, we're talking about years. Now, you want to think about how we approach this in our linear unit. What depends on what? Does time depend on population, or does population depend on time? If you said the second one, that would be correct. So since this depends on the time, or on the years, this would be our y value. So the y is our yearly population. And then our x value, which we have no control over, is our time. And you can be specific in saying that we're talking about in years. Now, we need to get into understanding the actual numbers in the equation. So the 90,000 is written first. So since we're talking about the yearly population, our a value is our starting value. So since we were talking about 1995, that's our starting year. How much was the population of this city? It was 90,000. So you want to write a sentence implying that. So in 1995, the population was 90,000. Now you can say the starting population was 90,000, something that implies. But if they give you the year in the actual problem, I suggest you actually write it. Now the second number is the 1.04. So notice that it's wrapped up in parentheses just because that means multiplying. But more importantly, it's next to the x value. So that's our b. Now, something that you should have already learned is if your b value is greater than 1, it's a growth value or a growth factor. So this population is actually increasing. It's increasing at a factor of 1.04. So you want to write the population is increasing at a rate of 1.04. Now you could use the word increasing, you could use growing, you could say the growth factor is 1.04. But as long as you use the vocabulary words, we will be okay. Now number 2 is just like number 1. It says the yearly value of the car after it's purchased is modeled by the equation. So we're talking about value of car over years. So then you have to ask yourself which one is our x and which one's our y. The time will always be your x value. Since we're talking about years, you can write years. If we were talking about months, you would write months. And then our y value is the value of the car. Now, just like in the above example, we have 20,000. But remember that we're talking about the value of the car. So in the beginning, or the original value, is 20,000. And now if you look at our b value, which remember is the one that's always next to the x value, you will notice that our b value is actually between 0 and 1. If your b value is in between 0 and 1, that's a decay. That means the value in this case is decreasing. So you can say the value is decreasing by a factor of 0.75. You could also write that it is a decay factor of 0.75, something along those lines. Now, number 3 is just like number 1. So I suggest you pause it and try it on your own. And then once you answer these 4, then hit the play button so you can check your work. So if you checked your work, the x is talking about years again. The y value is talking about the yearly population. $45, we're talking about the starting value of the y, which is in year 2000. So at the year 2000, you can say there was 45,000 people. And then, based on our 2 examples above, if you notice our b value is greater than 1, so it's like number 1, the population's increasing at that rate because it's greater than 1. And I'm just going to say the rate, I'm going to choose a better word, the factor, at a factor of 1.03. Now for the second standard, it says I can evaluate an exponential function and round to the nearest thousandths. So what you want to do is put into the calculator or put into your mind. Using decimals and exponentials, it's really difficult to do, but you can do it. So just like evaluating a function, what we did first semester when it was linear, we give you x equals 4. So you need to plug in a 4 wherever you see an x. So then y equals 200 parenthesis 1.05 raised to the 4th power. Now, a misconception. Students tend to do the 200 times 1.05 first and then raise it to the 4th, but you need to remember order of operations. There are no parentheses. However, you have to do the exponents first. So, on my calculator, 1.05 raised to the 4th power is a long decimal. So it is 1.21551. And then now that's times 200. And then you will get y equals 243.101. That's the answer. Now you don't have to show the steps. What we're asking you to do is just plug in the 3 into the x value and just simplify from there. So then 45 times 2 raised to the 3rd power is 384. Y equals negative 3 parentheses 4 raised to the 5th power. So 4 raised to the 5th power is 1024 times negative 3, which will get you negative 3072. Plug in the 2. 8 squared is 64. 2 times 64 is 128. So you can do that on the calculator at school, or if you have a TI Inspire, or if you have Desmos, you can do that as well. Now, the third objective, we can do part of with the knowledge that you have. So it says, now combining the skills from the 2 previous objectives, find the answers to the following questions. So eventually you'll be able to write your own equation. However, you don't have that information set yet. So I gave you the years, and we're going to use number 4 through 7 skill and apply it to 1 through 3 skill. So what that looks like is number 8. It says the yearly population of Southgate since the year 2000 can be modeled by the equation y equals 45,000 times 1.03 raised to the x. So what would the population be after 5 years? So if you look at number 1, if you look at number 3, you talked about your x value. Your x value was the amount of years. So I gave you how many years you care about. I gave you 5 years. So that's going to go into your x value. So you have y equals the 45,000. You know that it's growing at a rate of 1.03. And instead of x, you're going to put 5. Because in 5 years, in 2005, you wanted to know the population of Southgate. So if you put that into the calculator, 45,000 times the rate raised to the 5th power, you're going to get, and I'm going to put the approximation symbol, that number in the calculator. However, we are talking about population. So population can't be a decimal because we're talking about humans here. Humans can only be whole numbers. So we just round. So you can say, the population will be about 52,167 people. Now you're going to do that with number 9 as well. It says the yearly value of a car after its purchase is modeled by the equation y equals 20,000 times 0.75 raised to the x power. What would be the value of the car after 2 years? So if you would have looked up at the problems that you already did, we talked about 2 years, and you said that this was your x value. So you're going to put 2 into your x. So 20,000, 0.75 raised to the 2. Now when you are doing this on a calculator, even though you have 20,000 separated with a comma, you do not want to put that comma in the calculator. So 20,000 times 0.75 raised to the 2 power, because we're talking about after 2 years. So the calculator outputs 11,250. So you would say the value of the car would be that price. Which makes sense, because if you look at the problem, this is decreasing because it's between 0 and 1. So if you look at this problem, it's smaller than the original value. So you know that the value is decreasing. Now for number 10, we're talking about the population again, but here you want to pay specific attention to 1995, because it says, what will the population be in 1998? Now you don't want to put 1998 into x like you did for number 8 and 9, because you're telling the calculator to find in 1,998 years, what would the population be? But here it says, what would the population be in 1998? So you have to subtract the years. So 1998 from 1995 equals 3 total years. So that is what you're going to put into your x value. So just like number 8 and number 9, you're going to put 3 in. So then y equals 90,000 people times 1.04 raised to the third. Now when you really get good at this and you practice and you do what you need to, you're going to just look at this problem right here and say, oh, this is a growth. I know it's a growth problem because it's bigger than 1. So you should look at your answer or know that your answer is going to be bigger than 90,000 just because the population is growing. It's increasing. So let's check. So 90,000 times the growth rate of 1.04 raised to the third power. And if you put that into the calculator, it in fact is bigger than 90,000. So you can say the population in 1998 would be about 101,238 people.